Okay, we're live. So, let me just give it a minute before other people join. Disable alert says it needs permission. Okay. Give me a second.
Actually, we're good. I just need to.
Oh, you just need to sign up. Okay.
Yeah.
Yeah, I made that a requirement. Probably not necessary, honestly. Yeah, I'll change it so that anybody can edit. Everyone. There you go. Cool. Well then.
Hey.
I guess not many people are gonna come in today. I guess we can get started just like with the discussion. I don't think that there's. It's sad that there's only a few people. I feel like people are not aware that there is a calendar, so they don't add the events to their calendar. So only the people that are just happen to be in the Telegram at the time that I post about the call know that it's happening.
Yeah, actually, that's why I've been missing the previous calls. That's a good point. I'm gonna add the calendar.
Mm-hmm. Yeah. So, I guess we can get started. Priya mentioned on the issues that I had for this call a topic that she wanted to mention. Yeah, you feel free to speak.
Oh, I thought that was like an emoji. It's okay. You can like read it if you want to.
Okay, I'll read what you posted there. So you said, so to prove someone is over the age of 21 using a zero knowledge proof is pretty doable and simple because once it is successfully verified that they're over 21, then you never have to redo the verification because it stands true for the rest of that person's life. With this in mind, let's say someone is applying for rent in New York City and is requested to have a credit score of over 750 arbitrary numbers and cities, just for an example. What would be the best way to prove this? The previous example of someone being over 21 doesn't hold here since credit scores have the ability to fall. Since blocks are immutable, I've thought about a scheduled ZKP maybe once a year or at the beginning of the year or every release. But I'm wondering, is there any better way to do this, or has anyone thought of any thoughts on this? Cool. Yeah. So I have a couple thoughts. Does anyone want to start, or should I? Okay, I guess I can start. So, like, in order to create a zero knowledge proof of a credit score, you usually have to have either like a like a certification issuer or like someone that creates certificates. Like the certificates authority, CA is usually the definition for it. That signs on top of some like information that you have. It's really hard to have like on-chain credit scores because the source of the data itself is off-chain, right? So you either use a protocol that, for example, extracts data out of a TLS session in a decentralized way, like permissionless way. So you can use things like Deco. Deco is like this protocol that allows you to cryptographically verify the data in any TLS session. So you could be on your browser and access, let's say, your public profile that like shows your credit score, and you can essentially make an attestation to that credit score and verify that inside of a zero knowledge proof. So that's a possibility. Other than that, you just have to have like this certificate authority that signs, let's say like the US government branch for, I don't know, financial, I don't know who like does this, whatever like party that does like the credit scores for a specific entity and like creates these scores for them would have to cryptographically sign whatever your current your current credit score is, and if it's above a certain threshold, you can just attest to that it's above. You can make a range check for ZKP, and it would work. I think in the US there are private credit bureaus who produce FICO scores. Yeah, every country is different, so I guess just for the sake of abstractness, you can just use any party that is able to issue these credit scores would have to issue a set of certificates, and then you'd be able to verify that inside of a ZKP. Or you could sort of try to create your own on-chain, right? So in the future, let's say that on these different entities put the data on-chain, and you'd be able to just make attestations on some data that's encrypted somewhere. You could do either like fully homomorphic encryption and test to that to those things, or just do a various or they could provide a ZKP themselves, right? Which the user could provide, hey, I need these people to give me a loan or whatever, and I need to prove them a credit score. So can you please generate a ZKP outside out of my credentials and send it to them? That could probably be something you could do. But yeah, if the credit score falls though, that would be something that's harder to deal with during the time of the contract. Before the contract is trivial, right? Like if you don't meet the requirements, then you are not able to sign the contract. But like if during the time that I guess that's how it works anyways, right? Like you can sign a loan, and then if your credit score just falls below, then that only applies for the next loans. I don't think that it's like loans in the real life are atomic in the sense that if something falls underneath a specific threshold, you have to somehow comply with some other specific set of sort of requirements or rules. I don't know how that works, but yeah, I guess that's how you could do it. Anybody else has any other thoughts and questions?
Yeah, have there been efforts to do kind of credit or reputation scores based on just on-chain data? Because in that case, you don't have an issue with input data attestation if all the data is on-chain anyway, right? So all the transactions that you've made previously, which should contribute to your reputation or to your credit score or whatever it is, are all kind of trusted because, again, they're on-chain, they're on blocks that have already been appended to the chain. And then in that case, you could use you could basically do a proof of algorithm where the algorithm is the thing which aggregates all the data and then basically calculates like this FICO score or this risk score or whatever the thing is that you care about. I think in that case, probably the, I guess, trustlessness is okay because presumably that algorithm is snarked, and because the input is secure and the process is secure, then the output should also be secure. But in that case, you would want privacy, right? Like these big companies have, I think the FICO score formula, for example, is a humongous trade secret. And I guess if the banks ever had it, or if maybe there's a couple issues there. It's like a big trade secret, and I think also the banks don't really want to share data with each other, whereas credit score companies tend to aggregate data. But I guess the point is you would want the ZK part to kind of hide what the algorithm is doing, or at least like how the parameters are manipulating the data, so to speak, in the algorithm. But then I guess for that, you could have something like a signed ZKP, where the ZKP attests that the algorithm was run, and the signature attests that basically the correct party ran it. So if you have some trusted certificate authority, like DC Builder was talking about, that certificate could be the certificate that the algorithm is actually their algorithm, or is like their weights or whatever. So just, I don't know, other thoughts, I guess.
Yeah, for on-chain it's easier. The trust assumptions come in once you need to make attestations on off-chain data. Like if you only have data from, let's say, Aave, Compound, whatever protocols you use, attestations on top of that should be fairly easy to snark. However, that's full, the trust is fully encompassed in the chain, right? You don't have any other trusted party. That once you have off-chain data, you need to have these certificate authorities that are able to sign different things, and that's a lot of bureaucracy. It's easily socially engineerable, yada yada. The security guarantees there are much worse because it's not permissionless, not trustless. But yeah, you could still make attestations on top of those as well. You just need to have some sort of like verifiable data sources. So like things like Deco, for example, like I mentioned, where you can like extract data from a TLS session. So that would be nice for off-chain stuff. But yeah, like in the future, I feel like you could make like you'd have like a very nice sort of identity sort of framework where you'd be able to make attestations across different primitives in your life. So whether it's finance, whether it's like age or like document credentials, or whether it's like digital activity that you do, like let's say that like some rank in a game or some like number of followers on some social platforms that people know about, or whatever. You can like compose all of these statements together to make meaningful protocols on top of that and like build trust in like a fully digital system, and also uniqueness, which is nice. Does that answer your question, Priya?
Yeah. And then I don't know if this is kind of what Ryan was alluding to, but is there anything that is kind of building like a credit score across crypto transactions? Because I know that if you're trying to rent an apartment, you need to have a good credit score, but that means that you're using like fiat. But is there any way that you can have a good credit score if all of your transactions are on crypto?
If it's in the blockchain, you could make an attestation of anything, and you can even keep it private. You don't only have like the proof of correctness or soundness that like every single information is there. You could also hide like the actual final number, or like you can say like I have more than X, but you don't specify like which number you actually have in terms of credit score. So I don't know if there's people actually doing it right now using like ZK. I know that there's people that are doing it in a more sort of like economics point of view, where you have some value at stake and you can attest to some people being credible for an uncollateralized loan. And like there's like protocols like Goldfinch that are more like centralized, or like Aave Arc. Aave has like this protocol for more like big banks and centralized entities. I don't think they do under collateralized lending, but like it's very borderline. Like it's very capital efficient. I'd have to ask them like what if they do any under collateralized lending. But like the ones that I'm aware of is like Goldfinch, and there's another one that I don't remember the name of. And they just have like this system of like, there's a person that like guarantees, like a guarantor that this borrower borrows from the lenders in a pool, the lenders and some interest, and the borrower has to pay an interest. However, he does not have on-chain the equivalent or more for the amount he's borrowing. But if he fails to repay and defaults, then the people that guaranteed that specific borrower end up sort of paying the lenders and lose trust. So it's sort of like this system that like tries to economically incentivize people to not default on those and like have like some sense of responsibility and trust, which you sort of accomplish in the real world. But in the real world, you have like judges and just in general like a legal system that can like make your money appear if like a borrower like stops or paying or defaults. There's like other means, right? Like you can seize their assets, you can put them in jail, whatever other means there are, right? But on chain is harder because you don't have these methods to get it. So yeah, there's like this pros and cons, whatever you want. But yeah, I haven't seen someone use ZK attestations on top of some current like DeFi history that they have. It would be nice because you'd be able to aggregate data from different wallets that you have, then prove that you're a unique human and that like you don't have like more that you're not like multiple people, or you're using or misusing somebody else's credentials, and then like compose all of these attestations to sort of have an algorithm that creates or aggregates all of these data sources and creates you like a final score, and then you can make an attestation of the final score. I guess that would work.
Let's go back to the Web 2 sort of like example. what I've been trying to think about is sort of removing the need for doing credit checks. And my thinking is that if you can prove that you have a valid score and that you own this score and that you are the person that owns this score, you just have to prove that you have a score over a certain threshold. You could use a range proof to prove that you're over a 700 or something. But what I'm thinking of is, and you said Deco, and I know there's some other protocols that can, prove that you have that a score comes from like a certain trusted source, like Credit Karma or something. But what I'm thinking about is how could this all be done in browser or somewhere where a website, let's say, can trust that this is coming from you, from a trusted source, and that you own the score.
So to extract information from a website in a credible way, I mentioned this protocol. It's called Deco. I'll just put it in the chat if I find it somewhere. Yeah, they have a website even. One is the paper on archive, and then it's like an intro website. This is the paper. Wait, this is the Google link. Sorry, give me a sec. So this is the link to the paper, and this is the link to their intro website. They have like a short explainer on what it is.
Built this, I remember. I don't know if anyone's actually implemented it. Do you know?
Oh, I know that there's implementations of it. I just haven't seen like a mainstream product.
Right, that's what I'm asking. Yeah.
Yeah, I mean, there's implementations of it, as in like the protocol is written in code somewhere, and people use it for like various reasons. But I haven't seen it in like prod for like a very big application.
Yeah, I think only Chainlink, as far as I think Chainlink uses it, and maybe a couple other minor projects, but I think the opportunity could be much bigger for like actually replacing credit checks. I think that's what we should move towards. Or obviously there's other applications for it, but that's like the biggest that comes to mind.
100%. This is gonna take time.
Well, I mean, is there anything inefficient about it, or anything do you think's holding it back? I mean, this doesn't look too difficult to implement.
I think it's more about just like building a product that people want to use. It's not necessarily about it not being a very useful primitive. Like if you build something that's better than the status quo and you manage to do so because of Deco, then yeah. But like I doubt that just having Deco alone is gonna make you somehow like better than the existing products, even though like you could not achieve some certain things, right? Like the system is so like especially if you're talking about things like credit scores, like the systems are so like established and people are so slow at catching up to technology, especially if they're not like versed in the space. Like we're talking about like financial authorities that like have to like learn to do cryptography or like at least use an application that is easy enough for them to abstract all of these things. So I think it's just like that. And then you have to like lobby those applications into like being actually used in prod. It's just a pain. It costs money. You have to pay for engineers, maintenance. Like if something goes wrong, who do you ask for? Like it's just a pain.
I think it's going to be more of an identity problem. I think anyone can sort of prove a score with Deco. Now the real question is trusting the identity source, that attestation is correct, that it's from a trusted source. So what I'm thinking is maybe you could just have like centralized KYC providers attest to like a wallet or a browser session, and that's like sort of secured by your password or biometric, and then being able to unlock that, and by unlocking that you can provide a proof of your score. And I think you would need a way to tie your score to your identity. And you need to have an attestation that this is your score and that this is your identity tied to your score. I think you need those two steps to do this. And you need to have, and they both need to come from trusted sources. Your identity needs to come from a trusted KYC provider source, right? Government entity. And the credit score also needs to come from a trusted financial entity.
Yeah, for sure. There's like digital passports and like digital IDs in various countries, but you can make attestations, like cryptographic attestations on different like information on your ID or passport or whatever. However, you usually have to like sign an entire like passport or ID, so it's just hard to like just pick specific parts of the ID that you want to attest onto, right? So for example, when you're attesting to like your credit score, you might not want the individual to know where you live or like where you're from or whatever.
So it's a selective disclosure problem.
Yeah. So that's where like things like ZKKYC come into play, right? So you can make like a zero knowledge proof out of some specific parts that can be like cryptographically signed by some like centralized entity that issues the passport, and then you can make attestations within a zero knowledge proof on information within that passport, right? So you can like say, okay, this is my name, this is my identity number, whatever, right? So you know, even though it's the same name, it's the same person. This is my identity number. This is my credit score, and this is the attestation I'm making that like, yes, indeed, I'm qualified to get this loan for whatever reason.
Well, yeah, I mean, what they need to know is a few things. When you're even checking your credit score, you know, to go into the website, you have to give them your name, your address, and then your social security number. But if you're just showing it to an entity, if you want to buy a car, right, they just need to know that your credit score, your identity, and your social security number are all tied to each other, that they all are attested to each other.
Mm-hmm.
They don't need to know your social security number per se.
Yeah, they just need to know that that's
It's valid.
social is attached to the same person, and it's like, yeah. They wouldn't have to trust it because you have a signature from whatever authority that issued the credit score. Because the credit, like you'd have to only show it to the credit score authority, and you didn't have to show it to somebody else, as long as you can tie that.
Yeah, all they need to do is trust the authority, right?
Yeah.
Third parties, you know, transacting parties.
Yeah, that's the future. You know, like there's like a lot of cool things you can do with that.
I don't think it's too far off.
It's not too far off. Like there's people working on it. Like I know a couple teams personally that are working on ZKKYC. So it's like just making a framework that you can attest to different things inside of your passport and whatnot. Interesting things that we, for example, are also like thinking of at WorldCoin is that if you create, so WorldCoin is like this privacy preserving proof of personhood protocol that is based upon your iris biometrics. So you create a unique identifier using machine learning based off your iris. That's your iris image is taken using a hardware device, and it creates like a unique vector embedding or like a unique vector representation of your iris. And since the iris is very unique, if you manage to sort of compress that uniqueness to an identifier, you have no collisions. And then if you take that identifier, you can make zero knowledge proofs that you're indeed a unique user, and then you haven't performed a specific action. And if you, for example, put a ZKKYC protocol on top of that, so you can verify that you're a unique user, let's say in any application, and then you can tie that, for example, that your passport image, that it's embedded inside of your passport. You can create a vector embedding out of that, and you can do some like L2 distance and match like the two to each other. And if the person is the same, you can like attach the uniqueness proof to your sort of like proof of like government ID to do some like other miscellaneous attestations, which would be cool.
Where does machine learning come into play with this?
So it comes into play because you need some like convolutional neural network that's able to compress the information inside of your iris and create a unique representation out of it. So you need an algorithm that's fairly deterministic, that goes from input as an iris image, goes to a vector representation of it. And in order to do this, you need to use machine learning methods. Usually, you would use a convolutional neural network.
Interesting.
Yeah, so for us, for example, the reason why we even got interested in ZKML in the first place is because we have these people going to these hardware devices. We call them orbs. It's essentially just like a metallic ball with a camera on it, on different sensors, on an operating system, and a GPU, whatever, a bunch of things. And so if we update the machine learning model that's used to create the unique identifiers, we'd have to require every single user to go back to an orb and get rescanned so that you can recreate the unique identifier, right? Which is undesirable. So the cool thing would be if you go to an orb once and then you sort of cryptographically sign an image that you take in the orb, and then keep that cryptographically signed image like encrypted somewhere in your like mobile device, whether it's like the iOS secure enclave or some like Android whatever chipset that they use. And then every single time that we update the machine learning model, the person would just compute a ZKP on that encrypted image that they have on their phone locally, and they would provide the ZKP along with the new identifier created using the new model to a contract where we keep all of our users essentially. By users we mean just like a unique identifier that has no information whatsoever. It's just something that represents uniqueness. That's stored in a Merkle tree, and that's what we use to make like these zero knowledge proofs that all these users been signed up and all these user hasn't like logged in or like signed up for Facebook more than once or signed up for Lens or claimed a POAP or whatever.
I don't see really any reason why Apple couldn't sort of like implement their own version of this that doesn't rely on like outside hardware. You know what I mean? Like,
I mean,
Apple already is
you
rolling
really
out like wallet, like IDs on your wallet. So you already have
Yeah.
the form of identification sort of rooted to your Face ID and other biometrics that you can reproduce, and that could probably only be available in a single instance, which is your phone or any place you have Apple ID login.
I mean,
At that point, who are you trusting? Like, I mean, like Apple could sort of implement the same sort of crypto that you could reproduce with your secure enclave, right? Right. I mean, theoretically, Apple could certainly do all this, right, without having to rely on another like piece of
yeah,
hardware.
they could do all this, but like Apple like Face ID is so bad for this. Like the resolution you have for an image using like your iPhone that like creates the representation of your face is too small. You need specialized hardware for it. Like even to compute the identifier, you need to run a huge machine learning model, and there's no like trust guarantee. So you'd have to trust Apple that they run the algorithm on some like beefy server and then like encrypt it somehow, and you'd have to have like cameras that are a lot more efficient than they're right now, which like I'm not an expert in cameras. That's more like our hardware team, but we also have like sensors for like depth, like heat.
I think
This
iPhone has both of those. They have heat and depth, I'm pretty sure.
I mean, yeah, but like there's like different ones, like infrared, a bunch of stuff that like actually checks that you're a human. And as I understand it from like everybody else at our hardware team, it's impossible to create that identifier without having something that has more resolution. And then you also are not able to prove that the computation that happens is okay, right? Like right now, you're not able to create a zero knowledge proof of the model because it's just too hard, right? Like the model is huge. It's a bunch of like it's like 100 million parameters or so. So right now, the way that you do it is that you have trusted hardware, right? Like you have some hardware that you trust that's like running some VM that like does some state transitions that are valid and that nobody can tamper with them. And there's like some different tamper prevention mechanisms and some like cryptographic circuits embedded in the hardware. So like all of these things right now are impossible to do unless you have custom hardware. In the future, if you have what?
In this case, you're trusting this hardware, right? Your trust is somewhere. It's either what?
There's not been tampered with. That people are not emulating the sensors. That people like are taking an image from the right camera with the right like everything.
Also, I'm pretty sure the reason why Apple doesn't do this is because it doesn't provide any benefit for them. If you look at the way that they do any identification, like having driver's license in the Apple Wallet, they follow state laws or they follow country laws. So if Apple did have an identification system that they came out with, I don't see how that would benefit the Apple ecosystem at all.
Yeah, no, anyone's gonna have to follow state or like country sort of laws. Like identity, I think where all decentralized identity fails is being decentralized and not relying on, central institutions. Like the reason why identity isn't widespread today is less of an issue of the technology, but more of an issue of standards and adoption and sort of consensus on a set of standards. Like Microsoft proposed standards against like the W3C like years ago, and that kind of like slowed things down for years. It's because no one wants to adopt like a set of standards that comes from another sort of like institution with their own sort of corporate or like financial interests. And so a decentralized identity just doesn't work because of that reason. I mean, so Apple's case, like they're certainly just going to have to use state issued IDs just like everyone else. I think in your case for WorldCoin, though, obviously it's separate. You're more just trying to, it's more unique sort of proof of personhood. But I guess what I'm pushing back on is, Face ID may not be, high enough resolution to scan your iris, but I think it's a good enough tool for unique proof of personhood as well. I'm saying I think there's like other methods of like authentication of that.
I mean, yeah, but like you'd have an error rate that's just too big. Like we have an error rate like 1 in 100 million signups that like you can get like a false positive or false negative. I think it's 100 million or 10 million. So I'm not sure. But this is something that's like good enough for production. Whereas like Apple, I think it has like 95% accuracy, right? So like 1 in like
5 in 100, right? Like inaccuracy.
Like if you're trying to create a unique identifier for every single person using Face ID, you're gonna have lots and lots of collisions. Where people, you just don't have unique.
I think this is where like multi-factor authentication is really going to come into play, and I think this is just good overall for general OPSEC standards. Having multiple ways of authenticating yourself. Face ID, fingerprint biometrics could be one area, as well as a number of other factors of authentication that sort of like prove your personhood.
Yeah, for sure. Does anybody want to talk about anything else? Any topics, discussions, whatever you want to talk about? So that I don't impose like things that I'm interested in.
Did y'all try ChatGPT?
Oh yeah,
This stuff is crazy. It's
Sick.
so fun.
it's super cool. What's your favorite prompt that you used, or what's your favorite response?
I asked it to prove that Cantor set was uncountable, and it did. It was close, but the argument, like it did all the setup, and then it didn't do the proof. And I was like, okay, that's fair. But I don't know. My friends and I tried to make it into a DM for like D&D. It did okay. We're like, hey, we rolled like a perception 13, and it was like, oh great, you noticed a trap in the corner. And I was like, oh man, that's pretty good.
Oh wow, so it's playing D&D with you. That's pretty interesting.
Yeah, like we tried to turn it into a DM, so it did okay. It became more kind of instructional. So it started saying a lot of things like, oh, rolling a perception means blah blah blah, as opposed to like progressing the plot along. But it definitely had quite a bit of continuity. Like I think if OpenAI tried, they could make a pretty solid DM based off of GPT-3.
Very interesting.
Yeah, it's a good time. But I don't know. I think my bigger thoughts around all this are more in the realm of, I guess, just like education and our relationship with like reading and writing things in general. Not even from like an authentic stance, but from a like, oh, I have vague thoughts. I don't really know how to write, but that's okay because I can just tell ChatGPT to write it for me. And it'll get that across in like beautifully written language, which is kind of crazy.
What are some other prompts that y'all experimented with?
So this wasn't myself specifically, but my friend Miguel was trying to make sort of like a GPT chat sort of API reverse engineer. So like he reverse engineered the GPT chat API so that he could make a Telegram bot to talk to it, and just like instead of having to go on the
Right.
browser, like he had to implement this. He implemented it in Go,
Dang.
but like there's some like specific things that he couldn't do. So he was like, okay, there's this framework in JavaScript that does this thing that I want to do. Can you please rewrite it in Go? And like the GPT like literally rewrote it, like a full implementation of the framework that he asked him to. It worked. And it also like annotated every single thing that it did and why it did it. And even like did some like specific like thing that he didn't understand, where it was using a mutex, like a mutually exclusive piece of memory that you can like append to, which is like just some async issues that you have where like a thread like gets like issues. And he explained like he asked the GPT chat like, okay, why are you using a mutex here? Right. So and the GPT chat is like, okay, I'm using this because otherwise there would be like some like async data race on like the data that I'm trying to get from the API. Otherwise, like blah blah blah. Like it explained everything. And like gave him a full implementation. So he essentially built the API reverse engineer for GPT chat using GPT chat, which is hilarious.
That's super sick.
That's pretty good. Wait, ChatGPT should just rewrite all our code, but securely. Like, just feed it C++ and say, please remove all memory leaks, all race conditions, all possible like seg faults or whatever, and it'll be like, great, let me do that.
I mean, GitHub Copilot is getting like scarily good. Like I was like, I'm doing this cryptography course, and we have like different assignments from a book, and I had to implement like the first week was just simple. I had to implement the Visionaire cipher, right? So I typed the struct for Visionaire, and then like I do impl Visionaire in Rust, and then it just like auto completes the entire Visionaire cipher with a test and everything. Everything works. I presume that would be like just like he copied like the AI just copy pasted like an example that it saw before of Visionaire. That's pretty easy, right? But imagine like it's good at repeating these like operations with if you give it like good enough context, right?
Yeah.
If you give it context for what you're trying to do, it'll try to do it, and even though it like fails midway, it'll at least like automates like half of it, and it makes you super productive. It's great.
Yeah. Yeah, autocomplete is a fantastic use case just because, at least on the AI side, the way that these models are trained, or that at least the kind of classic GPT 2 and 3 series were trained, is literally to just do like next token prediction or like next sequence prediction, where it's like, okay, great. In the training set, what, like, given this context, what is the most likely next sequence of like tokens that I should be outputting or that would come from the train set? And so when it comes to, yeah, like you were saying, kind of like taking context and like pasting almost the rest of it, it's amazing at that. That is its objective. So yeah, it kind of makes sense. Anyway, play around with GPT. I saw a bunch of like memes where people were saying, "Ah, yes, write the lyrics to Apple Bottom Jeans, but pretend you're Napoleon, or like pretend you're, I don't know, like Barack Obama or some old like whatever like poet person." And it does pretty well. They're pretty good.
Yeah, what's gonna be interesting is when these responses, the LLM responses, are gonna be like cryptographically verified, and that's gonna allow you to prove that it came from a model as opposed to a human being. I think what would be interesting is like, I don't know if there's a way to like sort of crawl or scrape the web to see if there's a collision between something that the model has generated, or something that has some combination of text that has already existed, to see whether it's like an original thought or an original like piece of text. I think that'd be pretty interesting. At least this may help combat like Twitter bots, or knowing whether it came from a human or not.
Yeah, makes sense. I guess how does one cryptographically show or like sign that a model came or that some output came from, say, ChatGPT? I don't quite understand.
Apparently, they're working on this at OpenAI for a certain length of text, and the output is sort of encode the combination of the words in the output is an encoding that would represent that.
Oh, interesting. Okay, right.
So there's like a watermark inside of the text that's encoded with the text itself.
Yeah. I guess for something which is cryptographic and not like say distributional, then yeah, changing any of the tokens immediately breaks this, right? Like
You're saying
there's
like
no way to,
any text, if you change any word or something, or
yeah, or even just replace, for example, like a pair of parentheses with like M dashes or something like that, which is grammatically basically the same thing.
right.
But yeah, it's definitely a good effort. Like it makes sense. I'm just trying to think how they could actually pull this off, I
It's just
guess.
going to be a problem eventually when so much text is going to be generated, as opposed to like coming from original thought. And I just think that there obviously needs to be a way to distinguish the two. I think for LLMs, this is more of a difficult situation because text is so ubiquitous in the
Yeah.
world, right? Whereas images, it's much easier to embed like a watermark into a unique image that's generated, right? Or a video or something else. I think with text is where this becomes more difficult.
Yeah. Yeah, text is much more discrete in some sense, right? Like images, you can manipulate pixels pretty continuously, but text, as soon as you change any character, it's pretty obvious. Slash, it breaks the original.
I'm sorry, can you clarify the nature of the watermarking scheme that's used for text?
It's
Or
not
do
currently
you
being there. Like, from what I understand, is that OpenAI is looking at a way to implement this, but not currently active.
I see.
Yeah, I guess if I were doing it, then I would use some like something that resembles maybe like error correcting codes, where you say like, yes, I'm going to output words that like make sense more or less, but I'm also going to enforce that, for example, like a parity check, or I'm going to enforce that, yeah, just something akin to basically making sure that like some formula or some constraint on like the raw ASCII or like the raw bits is satisfied. Just because I guess like with regular human writing, no one would ever think about that. Like no one would ever say, ah, yes, let me consider like my word choices such that the ASCII values all add up to like some prime number or something like that.
I see.
But you could do this programmatically. But I guess as we were saying, this breaks as soon as you change even a single character, right? Like, and then you could easily just take the GPT output and then change like a couple of things which semantically don't mean anything, but which totally break the, I guess, like error correcting code or the programmatic scheme. Yeah, but all this is hypothetical. I have no clue. Like, I don't know what OpenAI is up to these days.
Oh, like you would put like you could imagine like making like an EIP 39 phrase. Like you could use like the word list for EIP 39 to encode like a message digest or something of that nature, right? I see. Yeah, so I thought that's quite interesting because, you know, like a lot of the rules of grammar or a lot of the, you know, like gender rules, like the rate of natural language is quite low. It's like there was some science paper a while ago where they measured it, and it's like the bit rate is very, very low. They had an ingenious method of measuring it where they would take experimental subjects and then like they would you know, do the thing where you listen to a speech at 2x the rate or something, or speed it up to 2x or something. They had some clever method based on that for measuring it. I don't quite recall exactly how it worked, but the finding was that the rate was very, very low, and that, you know, there therefore must be like huge amounts of redundancy in text, which I suppose is not the most surprising finding in the world, but yeah, like, I mean, I would say that there's a lot of degrees of freedom you have to play with for creating, you know, and encoding some kind of check. I don't know that it would be cryptographic though, but yeah, I think I see more of what you're saying now. Thank you. That's a good idea, I suppose.
Yeah, I mean, I hope it's successful. That'd be great. I'm personally a little pessimistic on the like distributional front in the sense that I guess having some soft detector basically say like, ah yes, the flavor of this word or rather the flavor of this phrase or this textual output appears to come from ChatGPT as opposed to like a human. Just because you can always prompt engineer and say like ChatGPT, please write this speech like in the manner of say like J.K. Rowling or in the manner of whoever. And ChatGPT should be able to do style transfer pretty easily. And also, like, the whole point of language models is to imitate text that humans have presumably produced. So, yeah, like
Yeah.
their whole purpose is to be distributionally like indistinguishable, basically, from what humans are writing. And so, trying to distinguish that, to me at least, seems a little moot. Almost like having a discriminator in like a fully trained GAN, where the generator is as good as like a human artist or whatever. But I don't know. Maybe there's a way. I'm not sure.
Yeah. So is it motivated, do you think, by the concern that they would sort of poison the well of the, so if they were, determining the parameters of their model by taking just large, like not very well discriminated samples of text from the internet, and, you could imagine within like 3 or 4 years of large-scale deployment of such things, like a very large fraction of the text on the internet could easily be generated by that very model. And so you would get this kind of feedback effect. And so you would need a way of cleanly excluding those samples.
Yeah, the feedback effect would be very interesting. Like having other language models train mostly on the output of their predecessors. That would be pretty funny, and a little bit circular, I guess. Yeah, I guess maybe the signing is more to tackle like a more immediate challenge of, oh, I'm a professor. I'm not actually a professor, but in theory, I'm a professor, and I want my students to write this essay, like summarizing this like treatise or whatever. But half of them just use ChatGPT, and I cannot tell the difference. And I have no idea how to like assign grades anymore because I can't. Like technically, it's not plagiarism. They're not copying it from anywhere. They just happen to get it from this large language model. So if there were some way to like sign the ChatGPT responses so that you could tell the difference, then the professor could at least try and like ban the use of ChatGPT or things like that.
Yeah, it's very obvious a problem. I think I remember once knowing someone who had collected like, tens of 20,000s of like college essays on Hamlet or something like that. Like it was like the thing that like basically everybody has to write. And they had like stats. I cannot remember. I mean, that sounds like a rather small data sample in this day and age, but
yeah.
But it was all on the same topic. And there's just like there's almost a genealogy of the essays, right? Like they all fall into like a certain category. Yeah, that was quite interesting. Yeah, I don't know. Okay, so they're not proving it's mainly like there's interest in watermarking, but not necessarily signing it, the actual internal operations of the model itself. So I think one of the applications we always thought was that you would be able to run a forward pass of the model on some kind of proving system, and you would be able to prove that every single step was followed of a sort of pre-registered model, right?
Yeah.
Like you would have, and that obviously seems kind of to impose a tremendous overhead on something of the size of GPT-3, like the DaVinci 2 save or something is just like, wow. So, I mean, that smells kind of like an open research question on, is there a way where you can have something that would, I mean, you might even have to relax the idea of proof because but some way you could have a proof that a given string was generated by the actual model.
Yeah,
Right.
absolutely. Yeah,
Like you would have like down to like, you know, the activation values of each attention head and all this kind of stuff, right? Like,
yeah, absolutely. So I guess maybe two thoughts on this. One is that, yeah, this whole like verifiable compute is, I think, precisely what a lot of us in ZKML are kind of interested in. That's what we're interested in at Modulus, of course. So we're kind of trying to work on like specialized provers that might be able to bring down the overhead to something reasonable for larger models, such as even potentially language models. And I think maybe on the like actual application or the effects of this, I think it's a little different from the thing that we were just talking about, which is trying to differentiate or sign basically GPT responses from human responses. In this case, it's more about showing that OpenAI is not cheating. So I think this is what Kobe and Louis were kind of talking about in the chat, basically making sure that the model provider or this cloud provider is not trying to take shortcuts. And for example, running a smaller model to give us purportedly ChatGPT outputs, but what actually turns out to be, I don't know, just some like poor AMT worker who's just like responding to all these random requests all the time. Yeah, so that would be more the application.
Yeah, I'm still not convinced that that's not the case. Actually, he's probably very good at programming. Whoever it is.
Probably, yeah.
Do the VM prompts. You know.
Oh my god, that would be that. That's whoever this person is. They're very impressive in their knowledge of the world.
Sure.
Yeah.
Okay. Has anyone like? I think I remember a couple of calls ago we were like asking about that a little bit. Is there like what do you guys assess? So you guys actively work in this field. Like what do you think is sort of the state of the art on getting like I know that I think Jason had built this really nice Plonk 2 system that could take an Onyx model and do proving on it. Is there some method that has anyone figured out a way that kind of like cuts down on the amount of computations that have to be encoded in the proof? Like,
yeah. So
like maybe with recursive proofing or say what is your feel on that?
Yeah, so this is, I guess, precisely what we've been working on in the sense that there's kind of two phases. So the first phase is to look at all of the current prover techniques and say, here are all the provers which kind of are and are good, tend to be good for like general compute, tend to be good for like building ZKPMs in, things like that. And let's just try and apply them basically to deep neural nets. So we're benchmarking a bunch of what we call multi-layer perceptrons. Basically, they're just feed-forward neural nets. It's nothing too fancy. But what it does allow us to do is it does allow us to see how the proof systems scale as the models themselves scale. And so this is one of the things that we're looking at. One of the faster, or honestly possibly fastest proof systems that we've seen is definitely Plunky 2. So they have basically they have Plonkish representation, which is awesome. They have like a Stark/Fry based polycommit, which is really awesome. And so it turns out that they're pretty fast. But even so, there might be other ways to basically have even faster, I guess, like structured compute or like structured proving, because these neural nets are so yeah, basically because the neural nets themselves are so like parallelizable or can be chunked up.
I see.
Yeah, but even with all of this, proving something like GPT is a little out of the realm of possibility for now. Yeah, it's going to be a little while.
Yeah, 100%.
Yeah, but yeah, it's super exciting stuff. Yeah, we're like on the very edge, I guess, of ZK working for a much, I think, larger class of problems than we were ready for a while now. So it's very exciting.
It's really insane. Sorry.
No, go ahead.
I was just gonna say that it's really insane just how far it's matured enough to be able to prove computations for like models that are this big. Like there's so many matrix multiplications in there, and you're still able to create like a zero knowledge proof in a fairly reasonable time. And it's getting like easier to prove bigger and bigger models with like less computational resources, and like it's just crazy.
Yeah.
I mean, yeah, I guess I apologize. This is too much of a kind of R&D-ish question, but like, I sort of can't help but wonder if like, if you were to relax the, like, you know, so what I would think of as a proof and the way it would work normally is that you can essentially mean that if a prover tries to cheat, meaning that they don't report every single activation of every single hidden unit in every single layer accurately, then the proof would fail, right? They would not be able to construct a proof,
Yep.
a valid proof.
Yep.
That would be kind of the condition. And that's an extremely strong constraint. And it might even be too strong for you know, what you would typically want to know in a machine learning application, right? You would like it would seem to me that like, so for example, if the output was a classification or something of that nature, then you would only really care about a relatively small subset of the weights and activations that sort of dominate the kind of end result, that, you know, the classification in your final softmax layer is this, right? So it would almost seem like you could only prove the activations and weights along that critical path instead of having to show all of the irrelevant sort of degrees of freedom inside this vast network. And it, you know, it would be almost like a kind of like a way a lot of these auto diff situations work, where you do like per example gradients or something like that, you know, like do you kind of, does that make any sense? Like, is and that seems like a way you can kind of, you could sort of relax this really strong constraint about what it means to prove that a certain, the result of running this large network was this. And instead you can kind of, you can sort of relax that. It still gives people mostly what they would want by the idea of a proof, meaning that, you know, the output, like the label, the classified label of this pre-agreed network is this, but it also, I guess it kind of opens up the possibility of a lot of savings. It has, I guess, there's got to be, there's so many people working on this stuff. There has to be somebody doing this already. I just kind of haven't seen anything like that. Do you guys know of anyone taking that kind of approach where they sort of, like, we just sort of give up on proving however many billion parameters or in something like, you know, Da Vinci 2 or whatever. And we just, like, there has to be some way to just save a lot of computational labor that way. Do you see what I'm getting at, or does that make sense? Or
Yeah, I think the idea is pretty intuitive, and I think makes sense. In terms of literature on this, the only thing that I'm mostly aware of is this paper called VeriML. So it's like VRIML. So they don't quite do what you're alluding to, which is like only proving that a subset of the operations were basically computed correctly. Rather, they try and do proof of training by having the verifier challenge basically random training steps within, I guess, like the entire training loop process.
yeah,
I think one issue, and I'm kind of talking out of my butt at this point, but I think one issue with this approach is that when it comes to cryptographic attacks, you need to assume kind of like the worst on the attacker's behalf. So if you even leave out, for example, one weight in like the final fully connected layer, the attacker can put any weight they want there, right? And so if the attacker chooses to put like 10 to the 20th or something like that there, that single weight will just dominate all of the other terms. And so the only thing that will matter is basically the output of that weight, I guess, multiplied against whatever the features are coming in. So I think because of that, I just like instability or like the linearity or whatever of this, it might be quite challenging to figure out which weights we can safely ignore in the network, or if there even are any that we can basically safely ignore.
Yeah, agreed. It seems like trying to leave out a lot of stuff would open you up to like all of these like adversarial examples where you can like add, you know, cleverly chosen noise and make the label whatever you want. Like it would kind of, I don't know. I could think of sort of vague arguments why it would go either way. Like it might even make it more robust. I don't know, but you know, but yeah, it does seem like